Hello everyone, Andreas here. This is the first part of a new video series about my next generation robot. It will be looking like this, quite similar to the last approach, but with some modifications and improvements, all the things I learned from the last robot arm. The video series will be basically I assemble one joint or element per video and publish the files. So in about 6 or 7 episodes everything is published. Some parts are quite difficult to source, so maybe it takes a few weeks between the episodes. But right now I have done the gripper. What you can here see is basically the 2 joints in the front. This is not the version I will assemble in this video series. That's my first test approach, but it will be looking quite like this. It's also a smaller version of the gripper where I tested the principle. So the new gripper is made with this molded rubber parts, just like the one on the open hand, and it has incredible gripping capabilities. So before I show you how the gripper actually performs, we go over with the construction. These are the printed parts. And I'm using some urethane rubber compound thing. 2 components. It's Vitaflex 30. So according to the data sheet, it has a density about around 1. So the CAD program says 1 segment should be about 4 grams. So we need about less than 20 grams. So it mixes 1:1. So and instruction says part B first. So yeah, gloves. Quite nasty shit. Fuck, I forgot. So, before we prepare, we have to seal our molds. For that, we use aluminum tape. And I have no scissors. Oh, god damn it! Oh, come on! Ja, warum ich den Funk haben wollte. Yeah, it just has to seal the bottom. So it's not really necessary. Ah. Ah, broken. Broken. Ah, damn it. Okay. We have now sealed the molds. No, the gloves. Okay, let's see. 10 grams. Now we have to wait until it's cured. Okay, the parts are cured, I think. And I'm using my electric thread saw I have in the basement for 10 years and never used to cut the molds open. So hopefully that works. I think I removed the aluminium foil first. Let's see. Beautiful. Really, really beautiful. All the parts we need are some bearings, a screw M4 by 40 and a nut and some washers, a few M3 by 20 and M3 by something of your choice. I use M3 by 16, and a super small bearing is 3 by 8 by 3, and of course a servo of your choice, standard size, and the printed parts. First you have to insert the bearing into the printed parts. I use this small clamp to do it. One. Yeah. And this separators. Next thing, we put some threads inside. Tapping. Okay, I forgot the mounting screws for the servos. Next is to put the M4 nut here. It's a tight fit. Then these two mounting screws for the gripper of your length of your choice. I put it in there. Then the servo. The gear. The small bearing. M3 by 20 screw. Check if the bearing is still moving. Nice. Okay, now the servo and the gear is connected. I used an Arduino with the default servo example with the knob and positioned it at one maximum. So now we have the servo in a defined position. We start assembling the claw, therefore M4 screw there, then the washer, the white bearing, then the green claw, a washer, the white claw, and the green bearing. And again a washer. After that, fit in the M4 screw. Now we move the gripper a little bit, or the servo a little bit off, close the gripper. So it's closed, but we have a little bit movement of the servo left to apply pressure. Then find a point and hook in the gears. Oh.
As you can see, we are now
Fully closed, more or less, and have still some servo movement left. If we are satisfied with the movement, can just tighten all the screws, put in the M3 by 20 on the sides. I prefer the hex versions of the screws, but unfortunately I have currently no M3 by 20 hex screws in the stock. So because this is the ball joint hex screw, you can just getting
inside
to mount it on the robot. Or if you have a different mounting kind, you can apply it first, of course. So let's do some easy task. Nice. 400 grams. Absolutely no problem.
Yeah,
So once again,
so I have here the pot to control the servo.
and let's grab some coffee.
So it's quite
A strong grip. The gripping capability is excellent.
You even can, with this fix hard parts in the front,
It's like fingernails. You can grip super small
parts.
and they quite secure. Or softer materials.
Or
even very small parts.
quite.
I'm very satisfied with the results of this rubber hybrid construction. If I compare it with this gripper, it's much more effective. The gears simply work better, in my opinion, than the wires. And this one is quite wobbly, so if the robot moves, you have, and even if you grasp something, you have this wobbly, which can be an advantage if you have a control system with, for example, a camera which monitors your thing, what you want to grasp, and then calculates the optimal position. But what's more in my intention for this robot is a system where you program some G-code and do some basically dumb tasks. So we need a gripper which is very reliable, and so that's so far my best approach. That's for episode 1 of this new video series. Next time we will assemble this part here, which is the wrist and the rotation part. Printed parts are already there. Thank you for watching. You can follow me on the social media networks where I post regularly updates and pictures about the things I'm working on. So thanks for watching. See you next time.